So we are looking at the back page of the second derivative test worksheet. Are we ready to talk about that, or do you need a minute? Should we start talking about number 9? Okay, so the question there is, suppose the function has a continuous second derivative for all x, and then they give us this information. F of negative 1 is 2, f prime of negative 1 is negative 3, f double prime of negative 1 is 5. Let g be the function whose derivative is given by, and then it's a huge mess. Does g have a local maximum or a local minimum at x equals negative 1? Justify your answer. So how do we even begin to answer that? Oh, don't be shy.
You see if g prime of x is equal to 0 at g prime of negative 1.
Good. So you're going to find g prime of x first. So you got to go through and do all the appropriate derivative rules. Plug in negative 1 and see if that's equal to 0. If it's not 0, then our answer is no, there's no relative min nor relative max there, because that's the minimum criteria. We have to get that it's a critical point. So the derivative has to be 0 or undefined, or it can't be a relative min or relative max. Were you able to evaluate g prime of negative 1 and get 0? Good. So then where do you go from there? I think Sam's carrying you guys. Somebody else needs to step up.
Double prime.
Oh, excellent. And then what are you going to do with the g double prime? Exactly. Plug in negative 1 and see if it's positive. Then that's going to mean we have a relative minimum. Or if g double prime is negative, then we're going to have a relative maximum. If g double prime is 0, then we don't know. It could be that there's a relative min. It could be there's a relative max. It could be neither one. We just can't decide. So when you evaluated g double prime of negative 1, what did you find out? Is it positive, negative, or 0? Positive, hopefully. So that tells us then what must be true.
There's a relative minimum.
So, and we would say there's a relative minimum at, remember you give relative minimums and maximums as ordered pairs. So you would say there's a relative minimum at, what's the ordered pair? Negative 1, 2. And that's why we needed that information in the very beginning about f. Since f of negative 1 is 2, that means the relative minimum is at negative 1, 2. Well done. Did we get a chance to start on 10 yet? Would you like a moment to do that? So you're going to have to use your, so you have the original curve given there. It's an implicit function because we can't separate out the y. We're told that dy dx is equal to 3y minus 2x over 8y minus 3x. So we need to find the second derivative. So you're going to have to use your quotient rule, fight your way through all that, and evaluate it at the point 3, 2. And then we're going to have to decide, does it have a relative min, max, or neither? And then you have to explain your reasoning. Oh, I should back up. On number 9, we had to justify it. So when it says justify why that's a relative minimum, you have to say 2 things. What would they be?
G prime of negative 1 equals 0.
And
G double prime of negative 1 is greater than 0.
and that's your justification for it being a relative minimum. Okay. Need a minute to do that? Okay, I'm going to pause the video so they don't listen to you guys crying as you try to find more.